Hello, this week we're going to be looking at our first Python classifier or Python implementation of a classifier, and this classifier is going to be k nearest neighbor or KNN. And the principle of KNN is that it uses a type of instant-based learning or non-generalizing learning. Sometimes you may hear it referred to as a lazy learner. And what this means is that it's not trying to construct a general model internally, but it's just storing during the training phase, it's just storing the instances that are provided in the training dataset. Then once we get a test sample, what it's going to do is calculate the distance between that test sample and each of the values on the training dataset, and based on the value of nearest neighbors, the k implies how many nearest neighbors you want to use. It will look at those closest neighbors and find out what class they belong to, and then do a majority vote with those nearest neighbors. We'll be using the scikit-learn implementation for this. But before that, we're going to have a look in step by step in detail at how the values are calculated. And we need to start by determining k, how many nearest neighbors we're going to be using. We can just define a value of k, or we can define a value experimentally. We're going to be calculating the distance then between the test sample and all of the training samples that we had during the training phase. Then we will sort those distances, getting the shortest ranking number 1, and then we'll find out the k. Here we have the k value, how many, if let's say k is 3, then the 3 nearest neighbors to the test sample. We'll check what class those nearest neighbors belong to, and then use the majority voting. The class that occurs most frequently in the nearest neighbors group will win, and that will be the class predicted. Let's have a look at a graphical implementation of this algorithm. So let's say we have our training phase contains values for, we have two classes, class A in blue and class B in red down here. And this is the training phase involves putting these points in storing the values in a space. In this case, it's a 2-dimensional for easy visualization. Now we're going to get a test sample that we want to classify, and I'm going to be putting this training sample over here. Okay, so let's imagine that this point here is the point that we're trying to classify. Okay, for simplicity, I'm going to be using Manhattan distance, which is the one that will run along the grid lines that are displayed. But remember, we saw a few weeks ago different distance measures, and make sure that you always choose the one that is most appropriate. So if we look at the distances between this point and the other points from the training phase or from the training sample, we can see that this point is 2 units away from this point in class A. It will be 1, 2, and 3 units away from this point in class A again, and it will be 1, 2, 3, and 4 units away from this point in class B. So if we were using k equal 3, we would be looking at the 3 closest neighbors. I don't need to continue calculating the distances to those other points. This is the closest point, this is the second closest, this is the third closest. And if we look at their classes, class A here, and class B, that means that this point using k equals 3 will be classified as belonging to class A. If we change the k value, we could get different results. Okay, now we're going to have a look at an exercise using actual data. So in this exercise, we have values for different measurements for 4 people, and those values are 28, 32, 33, 35, 27, 33, and 31, 36. And we know the class, in this case it's the gender for those people. The first point belongs to class male, the second one belongs to class male again, third one is female, and fourth one is female. And now we have a new person, and we take the measurements and we get 28 and 34, and we want our model to tell us if this person is male or female. To do this, we're going to fill in a table to calculate which one of the 4 training points are the closest nearest neighbors. We do that by calculating the distance. In this case, I'm using the Euclidean distance, and we get that value by taking our first feature from the test data point and the equivalent on the first training data, subtracting, squaring, and then plus 34 minus 32 square. Add it all up and we get 4. We do the same, 28 minus 33 squared plus 34 minus 35 squared. We get 26 and so on. You can try with the next 2 values. And what we're getting is a distance of 2 for the third between our test point and the third point from the training set. Distance 4 with the first point, 13 with the fourth, and 26 with the second. So the ranking would be, this is the closest point to our test data, second closest, third closest, and this is the fourth closest. So now that we know the ranking, we gather their, we go back for a second, so we look, the closest point belongs to class female, the second closest belongs to class male, and the third closest belongs to class female. This is what I was trying here. Okay, so first point was female, the closest, the second closest male, the third closest female, and the fourth closest was male. So if we're using a value of k equals 3, we're going to be looking at these 3 points only, and we do the majority voting over here, and we have 2 females, 1 male, so that means the result of our prediction is going to be female. So this is the basic functioning of the KNN algorithm. Now, using Python, excuse me, we can use what are called Voronoi polygons or areas, which are a way of graphically representing what class would our model predict a point to be. Okay, so basically, given the training, the points on the training set, we calculate the distances, and this is telling us that if we got a point in this area, it would be classified as green. If we got a point in this area, it would be classified as red, and so on. And even in the middle areas, it can differentiate between one class or the other. This particular example has been, because we have loads, a lot more of training points, we have been using k equals 15 for our number of nearest neighbors to use. We have 3 different classes, and remember, you can use different distance measurements. Okay, so now you have a video where I walk you through an example on how to use scikit-learn, the KNN implementation in scikit-learn, and then you have, that is a notebook, and then you will have an exercise in another notebook for you to submit for this week 7. Goodbye.